Hey, what's going on, everybody? Today I'm going to be taking a look at suspension bridges. My name's Bracken Cohen. I want to talk about why should you choose a suspension bridge, right, over any other kind of bridge. Um, what are the key components of a suspension bridge, and how do these components work together to form a strong structure? And we're going to summarize all this. So why a suspension bridge, right? That's the first question that we're going to ask. First of all, suspension bridges, they cover long distances, okay? They're very cost efficient. They're visually stunning. They're a good option for areas with extreme weather and seismic activity. This is the Kanakel Bridge in Turkey. It's the longest bridge in the world, longest suspension bridge in the world. It's about 6,637 feet, which is about a mile and a quarter or 1.25 miles long. And these towers reach about 1,096 feet. Talking about visually stunning. Look at this bridge right here. This is the Akashi Kaikyo Bridge in Japan. That's a beautiful bridge. And this is our Golden Gate Bridge out there in California. They said it'd take about 35 minutes to walk across this bridge. So let's look at the key components of a suspension bridge. Here you can see you have your foundation. I would call that the most important component of anything, really, is the foundations. All right, they're going to be concrete under the ground, and your towers are going to sit on your foundations. All right, so we have your towers sitting on your foundations here, and we have a main cable. The main cable is going to begin and terminate at each end of your bridge at your anchor points, okay? So your main cable comes up from your anchor to the top of your towers and back, and it terminates on the other side of the bridge. Then we have our hangers or our risers. These are actually what suspends your deck, which is the road that you're going to drive on. Okay, so we got foundations, towers, the main cables, and the hangers or suspension cables, and your deck. Okay. Now, a couple of things I thought people might be interested in is the foundations. Okay, they pour these foundations in concrete, and I know I asked myself I asked myself, how do they do that? Okay, so I figure everybody else is going to ask that question. So what they'll do is they'll shore off an area. Okay, they shore off and they pretty much it dams all this water. Well, that's still full of water, right? Even after they drive the shoring in there. Well, they'll pump that water out, fill that area full of rebar, and pour the concrete in it. And the result is going to be something along this line right here. That's a concrete slab or foundation. The other way they can do that is by pouring pillars. And this isn't in the water, but it's basically the same principles as they'll put a form down in the ground, and that's going to dam off the water. Same thing, they'll pump out the water, and instead of this 4x4 post here, they're going to use rebar down in there, and then they'll pour the concrete, and you'll be left with a concrete pillar. All right, the next component I thought everybody would be interested in are the main cables. Okay. So as you can see, the main cables, they're not just one cable, right? Obviously, you think that you got two cables on each side, but actually what these main cables are there many smaller cables that make one cable. Okay? I thought that was interesting. So let's talk about how these components work together. All right? just like it with everything else, you want to start with a good foundation. So they're pouring their foundation. The foundation is poured, they get their towers. All right. And your main cables ain't, well, then you're going to get your anchors. Your anchors are going to be down in the ground as well. And your main cables, you can see right here, they're under tension. They're coming over your towers. Now they're pulling on both sides of these towers. All right, there's tension this way and there's tension that way. And you think that's what stabilizes that tower. All right, and then you have your vertical hangers that are putting tension on your main cables. They're pulling down, they're holding the weight of this deck. All right, so that load is transferring to your main cable, which transfers it down to your tower. And since these are pulling both ways on this tower, that weight or that load is transferred down these towers into the foundations. And that's what provides the stability and structural strength of a suspension bridge. And now why the suspension bridge is good for areas with an extreme weather and seismic activity is they're able to move, right? So it's made of a lot of steel, and you think of steel as rigid, but steel actually does expand and contract. So if it expands and contracts with the weather, it moves. It's not going to be rigid and break, right? And the cables, obviously, they move. So in heavy winds, they move. In seismic activities, this structure is able to move, and they're designed that way. Okay. So to summarize, suspension bridges, they cover long distance. All right. They're more cost efficient. They're good for areas with extreme climate and seismic activity. We talked about that because they're able to move and they're designed that way. And they have stunning designs. I mean, they're some of the most beautiful architectural and engineering in the world. So I want to say thank you for watching this presentation. Again, my name is Bracken Cohen, and good luck on all y'all's.